So pre-calc, we're continuing our notes. I shared these answers with you, so you may have already copied them down, but I told you I would walk you through these types of problems because a little bit tricky to think about what you need to do to get the right answer. So because we want to be in this form where it's only one base with one exponent, now either one of them can be an expression. That means a combination of operations, numbers, things like that. That what you want to recognize first is there a common base? Is there a base that's the same between 25 and 5? And when you establish that you can rewrite 25 as 5 squared, I hope you agree that 5 squared is equal to 25, and that this 3x plus 2 is still there, and same thing, that's a times. X minus 2 is taken to the third power. Now I think you can recognize that you do have a power to a power that you can multiply. Just make sure that you multiply everything in that problem. So we're looking at 6x plus 4. That 5 is still there. Same with this 5. And then again, a power to a power you need to multiply. Just make sure you multiply everything. So we're looking at 3x minus 6. So just one more step, because we're multiplying with the same base, then we can add our exponents, and I would expect you to do this in your head, that when you combine like terms, 6x plus 3x is 9x, and 4 plus negative 6 is negative 2. So that's the answer we're looking for there. As we look over at the other one, again, the way I would do this might be a little bit different than a different teacher, but I would get 8 to be a base of 2. And with a lot of practice, you'll learn that that's the same thing as 2 to the third power. And then so 2 to the third power equals 8, so that 2x minus 1 is still there. And same thing with the denominator. I would probably just leave it alone. And one more thing, since I've kind of done a lot of stuff so far, is I'd go ahead and rewrite the cube root as to the 1/3 power. That's something we've talked about in the previous video. So now you can see a power to a power. You're multiplying those exponents. So that becomes 2 to the 6x minus 3. And while I'm at it, I might as well go ahead and when you divide with the same base, you subtract your exponents. So minus 3x. And notice I'm putting it in parentheses. That's important. And it's still to the 1/3 power. So I should be putting equals in here. So we're looking at 6x minus 3x is 3x. Negative 3 plus 6 becomes plus 3. And we're back to another power to a power, which we've talked about. You multiply those exponents. Just make sure you multiply each exponent. So 1/3 of 3 is 1x. And 1/3 of 3 is 1. That's the answer we're looking for. So again, I was just trying to walk you through because these are a little bit more complicated, but you can see how somebody else might work through the problems. So feel free to hit pause before we move on, and I need to show you how to use your calculator. Oh, not yet. I need the calculator in the next one. Anyway, so more practice. So again, the difference here is we are solving. And the whole premise is that you want to get the same base. So you have to think about, is there a base that is shared between 27 and 9? And if you think about it, you'll realize that 3 is the base that we're talking about. And the whole premise of this is that if the bases are the same, then the exponents must be the same. So 3 cubed is 27. That x minus 2 is still there. 3 squared is 9, and that 2x plus 5 is still there. Well, let's change colors just for dramatic effect. So now I can establish that the exponents have to be equal, and I need to make sure I multiply the power to a power rule. 3x minus 6 is equal to 4x plus 10. So what I would do is just subtract 3x to the right side. 4x minus 3x is 1x. Subtract 10 to the left side, and you get negative 16. And yeah, you can use a graphing calculator to check your work. So I'm kind of going to walk you through this as if you didn't even need to know how to do any of that. So what I'm going to do is go to y equals and type in both of those equations. So I'm talking about 27 to the x minus 2 power, and then 9 to the 2x plus 5 power. All right. And I already know my answer is negative 16. So what I'll probably do is just change my window to go from, I don't know, negative 20 to 0. And how about negative 20 to negative 10? Make sure you hit the negative key, by the way. If you hit a minus, it won't work. And then if I hit zoom 0, it'll fit perfectly into the screen with those x values. All right. Clearly, I can't see all of my window, so I need to change my y values to be, I don't know, 10. I think, no, even that's too big. I should have thought more about this. All right, how about this? I'll go from negative 17. You can see the issue with using a calculator. And then hit zoom 0. Let's see if this will actually fit in. There we go. That looks a little bit better. And you can almost see the point of intersection between the two of them being at x equals negative 16. This is probably a bad example to walk you through on this one. Maybe if I show you the table, second graph will find you the table. If I go backwards to x equals negative 16, you'll see that they share the same y value. So again, this is a bad example to walk you through using a calculator on. So I'll leave it at that. Let's look at the next one. Is there a common base between the 1/4 and the 8? And the correct answer is 2. Now you might be confused on how to get a base of 2. Well, if you ever want a fraction as a base, you just make sure you have a negative exponent. And then 2 squared gives me 4. And if you're confused, use a calculator. Is it true that 2 to the negative second power equals 1/4? Sure is. Change it to a fraction. So that x plus 2 is still there. Same thing with 8. 8 is equal to 2 cubed, 2 times 2 times 2, and that x minus 4 is still there. And the whole premise is to get the same base, so therefore the exponents are the same, and don't forget to distribute those exponents. Negative 2x, negative 2 times 2 is negative 4. Equals 3x. 3 times negative 4 is negative 12. So what I would do is add 2x to the right side, so that gives me 5x. Add 12 to the left side. 12 minus 4 would be 8. And you know me by now, I prefer those fraction answers. You know, if you write down 1.6, you are correct. And you could use a graphing calculator to check. I think I'll wait until I see a good problem before I show you that one. Same thing goes with the next one, is getting the same base. How about this? Go ahead and pause your video and see if you can work it out, and then come back and see that you get the correct answer. Because I would rewrite 4 as 2 squared. I would leave that 2x minus 7 alone, but I would also rewrite the square root as to the 1/2 power. And the reason why this might help me, x minus 1 cubed, is because I have the same bases, so the exponents must be the same. And as I'm looking at my exponents, multiplying by 2 and then later multiplying by 1/2 will cancel each other out. So I'm looking at 2x minus 7 is equal to, after I distribute this in, 3x minus 3. So as I solve this and I subtract 2x to the right side, I get x over here, and I add 3 to the left side, negative 7 plus 3 gives me negative 4. And again, feel free to pause the video, see if you can work out the next one, because I would get the same base to be 2 on all of these. If you were thinking 4, it's not a bad guess, except 4 to a power is not exactly 8. So that's your issue with that one. I started to talk about 8, so I wrote down 2 cubed. It's 2 to the 4th is equal to 16. X plus 2. It's 2 cubed will give me 8. X minus 1. And 2 squared gives me the 4. 3x plus 1. So as I distribute and I subtract exponents, 4x minus 3x is 1x. I get 8 minus negative 3, so it would be plus 11. And then over here, I get 6x plus 2. And some of you may need to work a little bit more out of this to get the right answer. Subtracting x over, subtracting 2 over, and you get x equals 9/5. But I want to keep this video somewhat short, so I'm going to stop right there. Again, the answer key, if you want to see somebody else's way of working through it, you can hit pause in the video, make sure you get the right answer. Hit pause in the video, see if you get the same answer. And again, he works it out a little bit more right here, so that might help you as well. Oops. This one. There we go. So here's the thing, is when we're solving equations, we want to make sure that we get the bases to be the same. But if we look at this problem, we kind of have an issue. 2 to the x plus 3. If I rewrite the right side, it'd be 2 to the negative first power, because that is 1/2. And then you get x plus 1. And then a power to a power, you have to multiply. We're looking at negative x minus 1. Over here, we get x plus 3. And then as we add x to the left side, that'd be 2x. Subtract 3 to the right side, we're at negative 4. So x would give me negative 2 when I solve it. I guess this one worked out fine. I was thinking it was going to be a situation where they never intersect, which is possible. You could have two exponential functions that never cross. This one was fine, though. As I move to the next page, what if we have a situation where the bases cannot be matched up? Well, that's where we're going to go to a graphing calculator. So here's a situation where it's impossible to get 3 and 2 to have the same base. So go ahead and read through the step-by-step process to get the answer. And then I'm going to walk you through a few of these problems down here. So if you don't read it, you can watch the video and see how I do it, and then I'll jump to the answer. So I kind of showed you earlier, except we had a bad example, so you didn't get a good example. So grabbing the calculator, go to y equals, and just type both of the equations into y equals. I'm looking at 2 to the x plus 1. And some calculators you need to put parentheses around, so you might have a calculator like that. Like if you use Desmos, just to give you a heads up, you have to put the exponent in parentheses because Desmos does the order of operations. My calculator, I do not. It knows exactly what I want. So let me go ahead and type it as if this were Desmos for anybody that has that. And so when you hit, I like to hit zoom 6 to go back to my standard window. You see the graph cross over here, and to find that point of intersection, you hit second, trace. The fifth option down is intersect. So as I move the cursor over, and your calculator is not that smart. You have to hit enter on the first curve, enter on the second curve, and then a third enter about where you think the point of intersection is. Because a calculator can only give you one answer at a time, what if these two cross multiple times? That's why you have to hit enter 3 times. So the answer we want, 3 decimals, is 0.839. We only want the x values. The reason why we only want the x values is the problem only has x's in here. The y in that graph comes from what the y value would be if we plugged in 0.839 into the problem. So go ahead and try the next two. Okay, so your equal sign is, to the left is y1, to the right is y2. See if you can figure it out, whether you're using Desmos. Desmos is easy. You just click on the point and it'll tell you what the answer is. So this one's y1, this one's y2, and let me show you the answers. Notice that there are times where they cross more than once, so that happens. So pay close attention to that, and make sure you do 3 decimals. And you should be ready for your homework. All right. Notice in your homework, when you are solving equations, if you can get the same base, I expect you to do that. And you can check your work using a graphing calculator. But if a problem is not possible to get the same base, like number 13, then you can use a calculator for all of it.